Hello students, how are you all? I hope everyone fine. So in last class we completed chapter called vector. So today I am going to start the new chapter, three-dimensional geometry. Introduction of 3D geometry you learn in first PUC. It is a continuation of that. But you can observe here, here we are not using more, okay, from the first PUC 3D geometry. We are using here more from the vectors. So immediately after vectors I am taking this chapter, okay. The reason is here we are using more concept from vector than the first PUC 3D geometry. So ನೆನಪಲ್ಲಿ ಫಸ್ಟ್ ಪೀಸ್ ಏನೇನ 3D geometry ಕಲಿತಿದ್ದು ಬೇಕಾಗಬಹುದು ಬಟ್ ವೆರಿ ಲೆಸ್. ಬಟ್ ವೆಕ್ಟರ್ಸ್ ಲಾಸ್ಟ್ ಕ್ಲಾಸಸ್ ಏನು ಕಲಿತಿರೋ ವೆಕ್ಟರ್ಸ್ ಅಲ್ಲಿ ಅದಂತೂ ಕಂಪಲ್ಸರಿ ಬೇಕು ಈ ಚಾಪ್ಟರ್ಸ್. ಓಕೆ, ಸೊ ಸಿ ದಿಸ್ ಫಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಇಸ್ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ದ the last concept of the vector, which is direction, cosines and direction ratios of a line. Okay, so this you know already, direction, cosines of a line you know because you learned this in first vector chapter. So same definition, same type of work we have now. So listen. If alpha, beta, gamma are the three angles made by the line with the positive direction of x, y, z axis respectively, then you know that direction cosines of a line is cos alpha, cos beta and cos gamma. Then first, okay, vectors alle kaltidiri. If alpha, beta, gamma are the angle made by the vector with the positive direction of x, y, z axis, here instead of vector we are considering line, and pele here instead of vector you will be having the line. So and line makes an angle alpha, beta, gamma with the positive direction of x, y, z axis. Then cos alpha, cos beta, cos gamma are known as direction cosines of the line. Remember here, okay, these are the direction cosines of the line, vector line. Now usually in this chapter direction cosines are denoted by LMN. LMN, small letter LMN and noted, right? It's nothing but the direction cosines of the line, See why this is required. See in first piece straight line kaltidare, we started with the slope. Because to understand exactly what I mean by straight line, okay, we must have what do you mean by slope. So slope ಅಂತ ಕಲ್ತ ಮೇಲೆ straight line ಕಲ್ತಿದ್ದೀರಿ. So ಅದೇ ತರ ಇಲ್ಲಿ straight line ಅನ್ನು ಡಿಫೈನ್ ಮಾಡಬೇಕಾದ ಸ್ಪೇಸ್ ಅಲ್ಲಿ we need direction cosine. So we begin this topic with the direction cosines. And direction cosines, okay, you already learned in vector, so here this will be easy for you. Okay, so remember the direction cosines will be usually in this chapter is will be denoted by L, M and N. Please remember that. Okay, again I will not define this, you know exactly what you mean by this, and you learn in detail about this in vector. So I am moving to the next important topic which you will not learn in vector but easy to understand, okay, from the definition. Observe carefully. Any three numbers which are proportional and directly proportional to direction cosines. Any three numbers, real numbers which are directly proportional to direction cosines of the line are called direction ratios. Any three number are directly proportional to the direction cosines of the line are called direction ratios. Proportionality and see, for example, 1, 3, 4. Suppose these are the direction cosines. 2, 6, 8. These are the number which is directly proportional to 1, 3, 4 alva. Multiply 2 to these three number, you get 2, 4, 6. So and this is called direction ratios. Aste adukke bere eno exact different definition illa. Any three numbers which are directly proportional to the direction cosines of the line are known as direction ratios. Adu negative agirabodu, don't worry, it can be a negatives also, okay, because -2 proportionality, directly proportionality, okay, is called direction ratios of a line. Nenpili direction ratios andre direction ratios are the numbers which are always directly proportional to given direction cosines. Direction ratios are any three numbers which are directly proportional to direction cosines of the line. So if ABC, usually in this chapter we represent direction cosines or direction ratios as A, B and C. So if I take A, B, C are the direction ratios of the line with L, M, N are the direction cosines, then relationship between L and M, A, B, C are as follows. A is equal to lambda times L, directly proportional. Adu positive agirbodu, negative agirbodu, non-zero, it should not be zero. Lambda times M, C is equal to lambda times N. Okay, it's okay. M N order achichade parvagilla. Artha aida? This meaning, the A is directly proportional to L. I hope okay you know what I mean by directly proportional. So B is directly proportional to M, C is directly proportional to N. So we can represent the relationship between direction ratios and direction cosines as follows: A is equal to lambda L, B is equal to lambda M, C is equal to lambda N. So artha aida ಎರಡು term direction cosines ಅಂದ್ರೆ ಏನು? Direction cosines, you know, if alpha of the line is nothing but if a line makes an angle alpha, beta, gamma with the positive direction of x, y, z axis, then cos alpha, cos beta, cos gamma are called direction cosines. In this chapter, these direction cosines usually denoted by L, M, N, so small letter. Next we define direction ratios. Direction ratio ಅಂದ್ರೆ ಏನು? It's three numbers which are proportional to direction cosines. So if usually in this chapter we denote direction ratios by ABC. So A is equal to lambda times L, B is equal to lambda times M, C is equal to lambda times N. And directly proportional. Okay. So now I'll give you one important note. It's very useful to solve so many problems because here you will get an exercise direction cosines to direction ratios to direction cosines. Directions cosines ಕೊಟ್ಟಿರ್ತಾರೆ, direction ratios ಕೇಳಬಹುದು, ಅಥವಾ direction ratio ಕೊಟ್ಟಿರ್ತಾರೆ, direction cosines ಕೇಳಬಹುದು. Okay, so ಅದಕ್ಕೆಲ್ಲ ಇದು ಕಾನ್ಸೆಪ್ಟ್ ಬೇಕಾಗುತ್ತೆ, ಅಬ್ಸರ್ವ್ carefully. Note, important note, ನೆನಪಲ್ಲಿ very important note. If ABC are the direction ratios, L, M, N are the direction cosines of the line, then you know that L by A, M by B, N by C is equal to K. Why? What is the reason? The reason is direction ratios are proportional to, alva, are proportional to direction cosines. The reason is this. To write like this, directly proportional, you know, already used in physics and in maths also in the previous year. Okay, so we can write L is equal to A into K, M is equal to B into K, N is equal to C into K. I'm not using the previous concept of or definition of direction ratios. I'm using that direction ratios and direction cosines are proportional. So I can write like this, directly proportional. So we know that from vector chapter, remember sum of square of direction cosine is always is equal to 1. ನೆನಪಿದೆ ಅಲ್ವಾ? So ಅದನ್ನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಿದ್ದಾನೆ ಇಲ್ಲಿ. So sum of square of direction cosines of a line, here also it is equal to 1, and L square plus M square plus N square is equal to 1. So use it here. This implies L, M, K and L, M, N ಅನ್ನು substitute ಮಾಡಿ you'll get K is equal to plus, ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? A square K, A square K square, B square K square, C square K square equal to 1, K square ಹೊರಗೆ ಹೀಗೆ ಬರುತ್ತೆ. Okay, so K, the constant is plus or minus 1 by root of A square plus B square plus C square. ಯಾಕೆ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ ಬಂತು? ಆಕ್ಚುಲಿ ಏನಿಲ್ಲಿ K square is equal to 1 by A square plus B square plus C square ಅಲ್ವಾ? So when you take square root, okay, K will be is equal to plus or minus with the square root ತೆಗೆದಾಗ plus or minus ಬರುತ್ತೆ, ನೆನಪಿದೆ ಅಲ್ವಾ ಇದು? So K can be positive or negative, so here also you will get plus or minus 1 by root of A square plus B square plus C square. Now substitute here, ಈ expression substitute ಮಾಡಿ. Therefore direction cosines of the line, when you know the direction ratios, therefore the direction cosines of the line with the direction ratio A comma B comma C are L is equal to, alva, therefore the direction cosines of the line with the direction ratios A, B, C are L is equal to plus or minus A by root of A square plus B square plus C square, M is equal to plus or minus B by root of A square plus B square plus C square, N is equal to plus or minus C by root of A square plus B square plus C square. ಹೇಗೆ ಬಂದು ಗೊತ್ತಾಯ್ತಲ್ವಾ? Substitute LMN in this expression. ಇಲ್ಲಿ substitute ಮಾಡಿ easily you can get the direction cosines from the direction ratios. You must remember this relationship between direction cosines and direction ratios. Direction cosines in the direction ratio very easily you can find out. Okay, sorry, direction cosines ಅನ್ನ direction ratio use ಮಾಡ್ಕೊಂಡು ಹೀಗೆ find out ಮಾಡಬಹುದು. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? So remember this information, very useful for entrance exam as well as to the board. Okay, L is equal to plus or minus A by root of A square plus B square plus C square. Actually what is the denominator? Is nothing but the magnitude of the vector, root of A square plus B square plus C square. Direction ratios of a line joining two points or line passing through 2 points. Okay, this is the direction ratios of a line. No other information is known, only the direction cosines of the line. Now we are going to find out direction cosines of the line passing through 2 points. So listen carefully. Here we have one very small, very important derivation. Observe carefully. Consider a line joining the points x comma x, like consider line joining the points x1 y1 z1 and x2 y2 z2. One line ತಗೊಳ್ಳಿ joining the 2 points x1 y1 z1 and x2 y2 z2. Okay, Let LMN be the direction cosines of the line. Let LMN be the direction cosines of the line. Let alpha, beta, gamma be the angle made by the line with the positive direction of x, y, z axis respectively. It ಗೊತ್ತಿದೆ ಅಲ್ವಾ? Actually ಇಲ್ಲಿ ಎಲ್ಲಾನು ಮಾರ್ಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ because this is a three-dimensional diagram and we are writing this in a 2D plane. So exact diagram is not easy to bring, not possible to bring, remember that. Okay, so just imagine that, okay, this line makes an angle alpha, beta, gamma with the positive direction of x, y and z axis respectively. Okay, draw PR perpendicular to xy plane, QS perpendicular to xy plane andre enidu ನೆನಪಿದೆ ಅಲ್ವಾ? This is called xy plane, the plane containing x axis and y axis. Draw PR and QS perpendicular to xy plane, as well as draw PN perpendicular to QS. Draw PN perpendicular to QS. Okay, construction artha aita? Okay, now I will show you how to use this construction to get the direction cosines of the line joining 2 points x1, y1, z1 and x2, y2, z2. Observe carefully. See, from the diagram you can identify, I told you this is not a perfect diagram because you cannot write the 3D geometry diagram in a plane. See, this line makes an angle alpha, gamma with the positive direction of z axis. Maybe this is a gamma. Suppose if I take this diagram as it is. Idu gamma adre idalli yav angle gamma, this angle should be gamma, no? See, I hope you know this. E angle gamma adre e angle gamma, right? Because this is perpendicular line, this is also perpendicular. I hope in a lower class you learn about this. Okay, so this angle is a gamma, so this angle is also gamma. Did you agree with me? Now this is a right angle triangle because this is a perpendicular line drawn to this line, correct? Now from this triangle, I hope this you understood. Okay, I hope you know this concept, because this angle gamma, then this must be gamma. So now from triangle PQN, define cos alpha. Cos alpha definition ಗೊತ್ತಿದೆ ಅಲ್ವಾ? Adjacent by hypotenuse. What is adjacent side? NQ or QN. Hypotenuse ಏನು? PQ. NQ ಏನು? See, this whole length is Z2, correct? This is Z1, this length is Z1. So what is Qn? Therefore Qn is equal to Z2 minus Z1. I hope you understood. Because Qn is nothing but Qs minus Ns. Qs Z2. Okay, this length is Z2, this is Z1, so this should be Z2 minus Z1. So cos gamma is equal to adjacent by hypotenuse, that is Z2 minus Z1 by PQ. PQ ಹಾಗೆ ಇರಲಿ. Okay, similarly we can define ಇಲ್ಲಿ ಇದನ್ನ ಡಿಫೈನ್ ಮಾಡಬೇಕು, ಇನ್ನೊಂದು ಡಯಾಗ್ರಾಮ್ ಬರೀಬೇಕಾಗುತ್ತೆ, but don't worry about that. So directly you can write similarly cos alpha is equal to x2 minus x1 by PQ, cos beta is equal to y2 minus y1 by PQ. Directly you can write just like this. So therefore direction cosines of the line, cos alpha, cos beta, cos gamma are the direction cosines of the line. So according to the definition of direction cosines, the direction cosines of the line joining 2 points, x1, y1, z1 and x2, y2, z2 is x2 minus x1 by pq, y2 minus y1 by pq, z2 minus z1 by pq. Now question comes, what is pq here? PQ ಹೇಗೆ ಕನ್ವರ್ಟ್ ಮಾಡೋದು? ಲಾಸ್ಟ್ ಇಯರ್ 3D geometry ಕಲ್ತಿದ್ದೆ. ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ 2 ಪಾಯಿಂಟ್ಸ್ ಅಲ್ವಾ? PQ is nothing but distance between 2 points. ಡಿಸ್ಟೆನ್ಸ್ ಫಾರ್ಮುಲಾ ನೆನಪಿದೆ ಅಲ್ವಾ? ಸೊ ಡಿಸ್ಟೆನ್ಸ್ ಫಾರ್ಮುಲಾ ಏನು ನೆನಪಿದೆ? ಫಸ್ಟ್ PUC ಕಲ್ತದ್ದು x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So when you know the coordinates of the point, which joins the two which gives us 2 points on the line, then direction cosines of the line can be found out using this concept. Direction cosines are x2 minus x1 by pq, y2 minus y1 by pq, z2 minus z1 by pq, where pq is distance between the 2 points. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಈ ಡೈರೈವೇಶನ್ ಎಕ್ಸಾಂಪಲ್ ಬಂದರೂ ಬರಬಹುದು. ಡಿರೈವ್ ದ ಡೈರೆಕ್ಷನ್ cosines of the line joining 2 points. Be ready for that. Okay, but more than that, the conclusion is very very important. Okay, examples and exercise problems that I will take related to this in the next class. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಡೈರೆಕ್ಷನ್ cosines, direction ratios, relationship between the direction cosines and direction ratios, and direction cosines of the line joining 2 points. We just learned this much in today's class. I hope you understood. This is just a beginning to 3D geometry. Important concept yet to come. Out of this last derivation is important. So important topic, okay, will come from the next class. So be ready for that. So we will continue in the next class. Thank you.